Alright, so today we are going to discuss the next step after the simple code. So far we we understand some instructions, right? We also understand when we have a couple of instructions together, right? 2 or 3 lines. And the next step would be we want to see a little bit more about some more registers. So let me remind you this slide once again, because you may remember that we have a list of general purpose registers, and out of those we know exactly accumulator A, accumulator B, they are 1 bytes. We have also worked with index register, a stack pointer, but we probably don't know exact purpose and especially why the names are like this: index register, stack pointer. So we don't know their purpose yet, but at least we know how to load data there, okay? How to do little operations with those registers. The ones that we haven't used yet, we haven't seen yet, are probably the last two: the program counter and condition code register, right? We haven't, I think, tried yet, right? We did nothing yet so far. So the condition code register will be the one that you will see here. So, since we have this bunch of registers, and most of the cases we load data, we do some operation, especially in accumulator A and B, which is together accumulator D. But the condition code register is a little bit different, because it's something like where you don't load the data, you do not control it. Most of the cases it's controlled by the microprocessor. So what happens, let's say excuse me, let's say you have you are doing some operations, right? And the computer, most of the cases, if something happens, let's say you are adding something, and you all have, I think, seen that example. Remember when you have a carry of 1, okay, and that carry is being ignored because you are not able to accommodate it within like 1 byte of register or within 2 byte of register, okay? Now that is ignored. But what do you think? Do you think after you ignored that 1, your addition is still right? You added something, right? And then you have a carry of 1, and you ignore it, because you have to ignore it because you cannot accommodate it in 2 byte. I think we all did that kind of, I think, instructions, right? So do you think still the addition is right? I'm saying the summation is right? No, right? It's incorrect. Now, what happens after that point? It's incorrect, so you did an addition, okay? Your microprocessor did an addition, and that is incorrect, and how do you know it? Because once the carry is ignored, nobody exactly know why the carry is, I'm saying there will be no notification that the carry is ignored. I'm saying you will not see it from the register, but there is notification somewhere else, okay? That is the condition code register, where you will see all those different kind of exception, okay? So basically, condition code register has 8 bits, just like 1 byte, so you have 8 bits. So each bit in the condition code register represents a flag. Now what does it mean by flag? Means if something happens somewhere due to some reason, some of the flags or one of the flag will be raised. What do you mean by raised? It becomes 1, okay? Because all these flags will be either zeros or ones. But anytime, if you want to know what exactly happened in the last operation, because these flags are being updated by every single instruction, okay, and it will only hold or demonstrate the status of the last operation you did. So let's say you just did an addition, okay, and you had a carry which was ignored because you are not able to accommodate into 2 byte register, or maybe into 1 byte register, right? So you will see it from here. You know it from this condition code register, because this condition code register is not controlled by you. It's automatically controlled by the microprocessor to raise those flags and show that, okay, something happened, and just read this one, you will know what happened. You see what I'm saying? Now, today we'll try to understand. As you see here, there is a sequence of flags. The leftmost 2 bits are always 1, but except those 2 bits, the other 6 bits, they have some names, right? I'm saying, let's say, starting from the right side, C flag, V flag, Z flag, N flag. Those are the names of the flag, okay? And they have some sequence. You see here, the last one is the C, and the next one is the V, and then Z, N. So they have their specific orders. So in this whole semester, we'll be talking about the last 4. So basically, C, V, Z, and N. These are the 4 register. 4 flags. We'll be exploring, and also we'll start from today. We'll know it first, and we'll see why when they are raised, meaning when they become set. Okay. Now, over the time, you will learn more about the flags. It's not only about the notification. You might wonder, why do you need the notification then? Okay. I'm sure that we'll have that answer soon. Okay. Because, as you see, we are answering one small thing at a time. So you'll get that answer soon, that why we need that notification. Do we really want to do something with that? Because, your addition is wrong, you know that, okay, or maybe you can get notification. You check the condition code register. You'll know it from here, but what then? Okay. After that, what? So you might know that answer soon. But today we'll first see when they are set. Okay. Which flags are set. Now, again, all of these bits are called condition bits. Anytime in literature you see condition bits, that means we are talking about these bits, especially condition code register. Now, in short, very basic, what we can say about the condition code register. Now, first of all, it stores the current values of the condition bits, right? Whatever the reason I said current, because every single operation will be changing those bits. Not all, some, or maybe all, it depends. We'll also show you which bits are affected by which operations. That's also given in the set of instruction. Okay, we'll show you from there. Now, bit changes means what? Either 0 or 1, because any bit, these are binary bits, so it may be either zeros or ones. Excuse me. And then after this slide, we'll always say bit is set. That means bit is high, or bit is clear, not set, 0. Okay. So anytime after this point, after this slide, we'll be always just referring, oh, okay, that flag is set, or that flag is clear. Okay. So set means 1, clear means 0. And also so the major reasons of these condition bits, they're set or clear, basically they come from subtraction, addition. Okay. Because that at the end of the day, the computer always just do the additions unless it does some kind of logical comparisons. Most of the cases it does addition. Okay. Or a little bit of logical operations like those, the AND, or, because it can do those directly because it has all those digital logic gates, so that's easy to do. But the arithmetic operation is the only one that's the only one arithmetic operation computer do, which is addition. Okay. Now, again, so here today we'll first explore the C flag. Again, we'll talk about all the 4 flags in the right side. So let's start with the C flag. So the question we want to ask is when the C flag is set, how it is set. Very simple. Let's say you are having an instruction where you are adding something. Because some instructions you add, right? You are adding something, and then you have a carry of 1. Okay. Then this is called carry flag as well. Okay. So the carry flag is set. That means C flag is set. Since you have a carry of 1. So this is one of the reasons why the carry flag is set. So when you are when you have an instruction, it may be, you know, we have a lot of different places where we do the addition, right? You have seen a couple of different ones, right? You know, so you add a plus b and you store it to a. Sometimes you add 1 with sp, right? So there are different places where you add. So anytime you are adding and there is a carry at the very end, which is basically ignored because you are not able to accommodate it, that is one of the time when the carry flag is set. Another time the carry flag is set, let's say you are doing subtraction. You know, there are plenty of places we do the subtraction, right? SUB, I think we all know that, right? SUBD, SUB. We have done several, I think, we have dealt with several instructions in quiz 5. So where you did the subtraction. Anytime you are doing subtraction like this, because what happens here, you are subtracting a larger number from a smaller one, right? In such cases, your carry flag is again set, because the subtraction is done for sure, but you have to borrow something from outside because you are subtracting a larger number from a smaller one. That's why. So these are the two cases when the carry flag is set. So just by looking at the addition and subtraction, we can directly say, okay, the carry flag is set. Okay. Any question here? Let's look at the next one. AND flag. You know, I'm not following the order because, you know, I just wanted to cover the easier one first. So the AND flag. AND flag is set. AND flag is basically called a sign flag. Okay. So anytime you are doing an operation, it may be addition, subtraction, or a little bit different than addition, subtraction. Whatever you are doing, if your operation results a negative number, anytime you get a negative number, then AND flag is set. Now the question is, which ones are the negative numbers? You know, in computer we have a specific way of representing the sign decimal, right? I'm saying all the numbers are basically the sign numbers unless you mention. So there is no sign, but the numbers itself represent the negative numbers. How do you know which ones are the negative numbers? Let's say just looking at the hex. Any number starting from 8, 0 are negative because, you know, it's 8, 0 or higher. All the numbers are negative numbers because the 8 starts with 1, right, in binary. So if you look at a number and the left digit, the very left digit of the number is 8. Let's say this one. The left digit of the number is 8 or higher. Let's say 8, 9, A, B, C, D, E, F. What happens? All this hex starts with a 1, right? In the very left side. So this is the binary. So binary of 81 is what? 1, 0, 0, 0, 0, 0, 0, 1. Anytime you have a 1 at the very left side, that means that is a negative number, because if you convert it to the sign decimal, do you remember the sign decimal number system? Anytime you convert these numbers into sign decimal, these numbers becomes negative. So here, if your result is negative, okay, so let's say you are getting a number, and the number, you know, you probably will know it now from the hex number, just by looking at those, that if the left digit is 8 or more, then it will be a negative number. Okay, so anytime your result is negative, then this AND flag will be set. Any question here? It's not too hard, I think. Now the next one is Z flag. Anytime your result is zeros, okay, doesn't matter what carry you have, but if the result is 0 itself, okay, so basically let's say you are storing something into register, let's say, or in any memory locations, but the content is 0, absolute 0. So then the 0 flag is set, which is also very easy to understand. Now the most exciting one is the V flag. Okay, so the V flag is called the overflow flag, and technically this flag is set when the sign of a number is not right. Now how do you know exactly when the flag is set? Now let's look at this slide. This slide is really useful because the I try to symbolize the rules here. So for an example, let's say you are doing an addition, okay? And in case of addition, let's say you are adding two positive numbers, okay, but the result is negative. Is it possible? It's not possible in decimal world, right? I'm saying you are adding two positive numbers and the result is negative. It's never possible in the decimal world, but it's possible in the world of signed decimal, because what happens, let's say you are adding 70 plus 20, okay? Now look at 70, that's a positive number. 20 is also a positive number, but when you add 70 plus 20, your result will be what? 90? I'm doing a hex addition. 90, what is 90? It's a negative number, right? As I said, anything larger than 80, starting left side is 8, is a negative number. So the 70 and 20, both of those are positive numbers, but if you added those, the result is negative. So that's possible. So that's one case. Another case under addition is you are adding two negative numbers, but your result is positive. Okay? So these are the two cases, the two addition cases when reflex said. In case of subtraction, okay, let's say you are subtracting and both of the numbers have different sign. Do you see that both of the numbers have different sign? In case of subtraction, both of the numbers are has different signs. So basically one number is positive and the other number is negative. But the result, whatever the difference you get, has the same sign like subtrahend. You know, the bottom number is called subtrahend, right? Here, in case of subtraction, the top number is minuend, and this is subtrahend. So you see here, I tried to mark here, just to make sure you understand what we are saying. This should have the same sign, okay? In case of subtraction, if you are having two numbers with two different signs, if you are subtracting, but the result has the same sign like the subtrahend, then V flag is set. So these are the four cases when the V flag is set. Any question? We'll need a lot of practice for sure, just to make sure we understand the V flag. Okay? But these are the rules, and you know, this slide will be extremely useful. Now let's look at a couple of examples. Let's say you are adding 2a plus 2a. Let's try this. So the answer we want to know is which flags are going to be set out of all these four. Okay. Now let's look at how we get this. So 2a plus 2a, the result is 54. I think we don't have any doubt about the hex addition. But let's look at the result. 54 is not a negative number, right? So the negative flag is not set. It's not 0 either. So the 0 flag is not set. There is no carry either. There is no borrow either, because you know you don't have to borrow in case of subtract addition. So the carry flag is also not set. And also look at this. You are adding. Both numbers are positive, right? 2a is a positive number, and the result is also positive. So the V flag is not set either. So you know there are cases when no flags are set. It's not required that the sum flag has to be set. Okay. So none of the flags are set here. Let's look at another example. Let's say you are adding 91 plus 91 here. Okay. Look at the result here. So the result is 22, right? But there is a carry of 1. So what happens? N flag is not set because this is not negative. Which is not negative? 22. Okay. Don't consider the carry, because you know the carry is out of the picture right now. So just look at the result. So the result is 22 here, which is not negative. So N is 0. It's not 0 either. 0 is not set. So there is a carry. We can see it for sure, right? So that's why the C flag is set, right? How about the V flag? Look at the numbers. You are adding, right? And both of the numbers have the same sign, because both of the numbers are negative. 91 is a negative number, right? Both of the numbers are negative. You are adding, but the result is 22, which is a positive number. so the V flag is set. Because this is one of those 4 categories. Let's look at one more. You are doing subtraction, B1 minus 7C. Let's say you are doing subtraction, and you get 35 here. Now what happens? 35 is not negative, so negative flag is not set. It's not 0 either. And there is no carry or borrow. You know, this is a subtraction, so there might be a borrow, but there is no borrow because B1 is larger than 7C. But look at the numbers carefully. This is a negative number, this is a positive number. So you know, you are subtracting a negative number from a positive number, but look at carefully here, the result, the difference is also positive. So basically the 7C and 35, they have the same sign, right? Both of these numbers are positive, but this is negative. Remember, there was a case. These 2 numbers should be different, should have different sign, but these 2 numbers should have same sign. Then V flag set. That's why the V flag is set. Okay. Now we'll go to the quiz section. The next quiz, which is quiz 6, waiting for you, is on the flags. Every question you will see an addition or subtraction. Okay. And you have to choose all the flags which are set. It may be just one flag. It may be multiple flags. It may be no flag. You know, we saw an example where none of the flags are set. Okay. So, and also, let's see whether I can find that slide. Okay, and one more thing from the set of instruction. So, if you look at the set of instructions, you will see at the very last right side, I'm saying very right side, there is a column, title is condition codes. Do you see it? Under the condition code, you have all these flags written. Especially, you know, we just, you know, we want to see the NZVC flags, because those are the flags we just know, right now. And do you see these little triangles here? Now, the triangles means, let's say under ADDB, you have 4 small triangles. That means if you are doing ADDB, any of these 4 flags can be affected. That's why there are triangles. Okay. Now, for an example, let's say you are doing AND A. Look at the right side. What do you have? So under AND flag, there is a triangle. That means AND flag can be affected. Z flag can be affected, but V flag is 0. That means V flag is affected, but that will be always 0. So it will never be set. C flag, there is a hyphen here. That means C flag will never be affected by AND A. You see what I'm saying? So you will know also from here which flags are set or cleared, but by which instructions. Okay. At this point, we are not answering that question, but over the time we'll know it. We'll know this and we'll need it for sure. Okay. Just to know which flags, you know, even with some of the instructions. Look at ABX and ABY. Look at the very right side. All the flags have hyphens. That means none of the flags will be affected by these instructions. Okay. Now, what do you mean by not affected? Meaning their status will not be changed. If there is a triangle symbol, that means there is a chance that it might be changed. You see what I'm saying? It's not guaranteed that it will be changed, because, you know, it depends on many other factors. But whenever you see a triangle, that means it will be affected by the result. There is a chance. Okay. So you'll know it from here as well. But at this point, since we just started the flag, so in the quiz we'll just answer which flags will be set by that addition and subtraction, because, you know, you will see just bunch of instructions, not instructions, additions and subtractions. Okay. For each addition or each subtraction, you just have to tell us which flags will be set. You have to choose all the flags, maybe only one, maybe none. Any question? And this slide is also under the content section, so you can always see the slide and answer that question.